We have a question here. A hot metal weighing 100 grams and temperature 300 degrees Celsius is put into water which is at 10 degrees Celsius and weighing 250 grams. That's the weight of the water. The question is to find the specific heat capacity of the metal if the water temperature increases to 25 degrees Celsius. Initially, the water was at 10 degrees Celsius. Now it increases to 25 degrees Celsius. We need to find the specific heat capacity of the metal. Now let's record the information given here. We have the metal and then we have water. Now the initial mass, the mass of the metal is 100 grams, that is M, and the initial temperature T of the metal is 300 degrees Celsius. Same way for the water, the mass is 250 gram and the temperature is 10 degrees Celsius. Now, when we put this hot metal into water, what's going to happen is the metal is going to get cooled down a bit and the water gets heated up. Obviously, as we can see, it becomes 25 degrees Celsius. So all the energy that's getting you consumed in heating up the water is coming from the metal. The metal gives out the energy. That means the energy spent by the metal is the energy gained by the water. Both are same. And we know that that is given by this formula. Q equals mass times specific heat capacity times change in temperature. So we need to find Q for both metal and water and equate that and try to find the specific heat capacity of the metal. Now we are also given a specific heat capacity of water which we can use here. Now first let's calculate the energy from the metal side. Let's call it Qm. Mass is 100 gram, so we convert to kilogram. 100 times 10 power minus 3. Specific heat capacity of metal C is what we need to find out. Let's keep it as C. The change in temperature. Initially the metal was at 300 degrees Celsius. Then it drops to 25 degree. Both water and metal are at 25 degrees Celsius. The change is 300 minus 25 to 75. Now let's calculate the same energy for heat for water. This is going to be the water, the mass is 250 times 10 power minus 3 for kilograms. Specific heat capacity of water is given as 4200 and the change, water was initially at 10 degrees Celsius, it increases to 25, so the change is 15. Let's equate both. So we need to equate both 100 times C times 275 is equal to 250 times 10 power minus 3 times 4200 into 15. Now from this, if we isolate C and calculate, we will get C to be equal to approximately 572.7 joule per kg per Kelvin. Now this is going to be the specific heat capacity of the metal.